दीवाना बन गए हैं। मैं कल शाम को भी क्या था पर्दे के पीछे मैं क्या चल रहा है आ जाऊंगा पक्का, ठीक है। पर्दे में रहने दो। Before we start the lecture today, we need to revise whatever we have done yesterday. It's a very minor thing, but these topics are so wonderful that well, almost अगर मुझे साथ दो रोज याद हो जाएगा। So you just start from here. Sure. What is the force acting on a charged particle in an external magnetic field?
So, QVB sin theta.
It is QVB sin theta. ठीक है जी? What is the direction?
The direction is given by the right hand rule and it is V cross B.
V cross B. Always V cross B.
So it can be minus V cross B and in that case.
If the charge is positive, it is given by V cross B. Okay. Joy. When does a charge not experience a force in an external magnetic field? Never. When does a charge not experience a force in an external magnetic field? हाँ जी जय। What is theta? Who all are parallel? Me and you? Charge is a scalar quantity. It doesn't have a direction. What is parallel? Aish.
Velocity and magnitude.
Check yourself. There's no harm in saying things wrong. इसे करके रोज पूछता हूँ। जिसको आता होता है वो सोचता है क्या पूछ रहे हैं। When the velocity vector and magnetic field are parallel to each other, it experiences no force. The charged particle passes through the region unmindful of the magnetic field. It doesn't even bother about the magnetic field. The magnetic field will not affect it at all. It is as if the magnetic field did not exist. और कोई condition?
When the velocity is zero.
Why is there such a frown on your face when you say this? When the charged particle is at rest. When the charged particle is at rest, it experiences no force. इलेक्ट्रिक फील्ड के बारे में बात की थी कि नहीं? ओके हैं? बात बन जाए। और we know that if the charge is moving at an angle other than 0 or 180, it will experience a force. What is the angle the force will make with the velocity vector? What is the angle that the force acting, because the force will act, will it make with the velocity vector? 90 degree. 90 degree. And with the magnetic field? 90 degree. 90 degree. Because cross product है ना? Question का जवाब question में ही होता है. If you just view it, you don't have to remember it. You just have to have a way about it. F is V cross B. So F is perpendicular to V and F is perpendicular to B. V and B need not be perpendicular. कैसे भी आ सकता है पार्टिकल यार. In which case is the force acting on the charged particle maximum?
When V and B are perpendicular.
When V and B are perpendicular, and that force comes out to be
QV.
ठीक है? पहले यहाँ से हम magnetic field define करते हैं, and then I'll make you write something about the electric field as well. For theta equal to 90, F is QVP and B is F over QV. If Q is 1 coulomb and V is 1 meter per second, then V will be equal to F. V is 1 Newton over 1 coulomb into 1 meter per second. This will become क्या बन गया? एम्पियर. 1 Newton per meter per ampere. It is called 1 Tesla or 1 T. The magnetic field is said to be 1 Tesla. The magnetic field is said to be 1 Tesla if a charge of 1 coulomb moving perpendicular to a magnetic field with a velocity of 1 meter per second. Moving perpendicular to a magnetic field with a velocity of 1 meter per second. Experiences the force of, क्या कहते हो? 1 Newton. Experiences the force of 1 Newton. डायमेंशन निकाल के दिखाओ. Exactly, they are very, very simple. Like, it would be MLT minus 2 into meter, L minus 1, ampere minus 1. Or it is simply MT minus 2, A or I. ठीक है? Note. इंटरेस्टिंग बात है यार. अच्छा, एक बात बताओ, पहले लिख तो देंगे. Static charge produces an electric field or a magnetic field?
Electric field.
And a moving charge? लिख it. A static charge produces an electric field. Static charge produces an electric field, whereas the moving charge produces both an electric as well as a magnetic field, whereas the moving charge produces both an electric as well as a magnetic field. Code note. पहले बात करते हैं. If a charged particle is at rest, charge is Q, positive, electric field is E. What is the force acting on it? If the charge is moving? If the charge Q is moving at an angle theta to the electric field, then? A charge Q, a charge Q is moving in an external electric field E at an angle theta to it. What is the force acting? Why? किसने बताया? It will be given to you only. मैं तो वैसे ही कंफ्यूज कर रहा हूँ. The force acting is बड़ा जरूरी है मेरे लिए. We will always do things about the magnetic field and try to answer the same about electric field, which we have already done. We will confuse ourselves and then come out of the chaos. दोनों बातें इकट्ठी पूछेगा आपसे. ऐसी क्या बात होगी? Actually मैग्नेटिक फील्ड का चक्कर है. इलेक्ट्रिक का वो चक्कर नहीं है. इलेक्ट्रिक फील्ड will always be Q into E. अच्छा, एक और बात. What is the trajectory of a charged particle plus Q in an electric field if the charged particle is at rest? Straight line, obviously, straight line. If the charged particle plus Q has a velocity along the direction of the electric field. If it is perpendicular? Parabolic. And if it is at an angle? नहीं, ऐसे भी तो आ सकता है. It is still parabolic. ठीक है? अब एक बात बताओ. Tell me a case where there will be no change in speed for a charged particle moving in an electric field. Tell me a case in which there is no change in the speed for a charged particle moving in an electric field. There is no such case. A charged particle electric field ਦੇ ਵਿੱਚ अगर है तो उसकी हमेशा स्पीड बदलेगी. Do you remember this small story कि if a force is acting, then in what case does the speed change, and in what cases does it not change? This was my lecture of circular motion, the first lecture of circular motion. Let us quickly revise. Revision note. We remember अगर आप वेलोसिटी लेते हैं और यही फोर्स एक्टिंग है. If the force is parallel to the velocity vector, na, it will surely change its speed. I'm not talking about electrical and magnetic at the moment. I am just revising a mechanics concept. That any force, if a force acts on a particle along the velocity vector, then it will surely change its lift. अगर कोई फोर्स वेलोसिटी के परपेंडिकुलर लगती है तो फोर्स का कोई भी कंपोनेंट वेलोसिटी के अलोंग नहीं है. स्पीड सिर्फ तो इंक्रीज होती है At least there should be a component of the force parallel to the velocity. If the force is perpendicular to the velocity, there is definitely no component of the force.
Changing its velocity.
Changing its speed. There will be a change in its direction. अब स्पीड कौन बदलेगा? और एफ साइन थीटा बहुत इंपॉर्टेंट है ये बात सारी। इफ वी हैव टू अंडरस्टैंड कि कैसे स्पीड बदलती है और कैसे डायरेक्शन। Let us put another note and revise our trajectories of the charged particle in an electric field. ठीक है? Good. Revision note. Motion of a charged particle in an external electric field. Motion of a charged particle in an external electric field. ये प्लस क्यू चार्ज है और ये इलेक्ट्रिक फील्ड है। फोर्स कहां और कितनी लगेगी? हाउ मच? On the basis of this discussion, will there be a change in the speed?
Yes, sir.
Surely. It will acquire a velocity along the direction of the field. The force acting is along the velocity. The force acting is along the field has no link. The force is acting along the velocity because the velocity acquired will be along the field. ठीक है? Force and velocity in the same direction. Surely a change in speed. Trajectory क्या होगी? Trajectory is a straight. Velocity ऐसे, force की क्या डायरेक्शन है? Remember, the force acting does not depend upon the direction of velocity. ठीक है? ये लगी फोर्स कितनी? इतना क्लियर है यार। F is along Q, F and V in the same direction again. There is surely a change in speed. And the discussion as above. कैसे आया चार्ज पार्टिकल? परपेंडिकुलर टू द फील्ड। अब फोर्स एक्टिंग किधर है? Exactly. So I think there should be no confusion. Yeah, how can it depend upon V? It is Q into E. So velocity, the angle between the force and velocity will decide whether there is a change in the speed or not. Charged particle can come along any direction. मैंने रेस्ट पे भी रख लिया, along the field भी डाल दिया. But force is always, the direction of the force does not depend upon the direction of velocity. ये होगी जी force acting. अब बोलो, will there be a change in speed? Careful. मानते हैं कि t is equal to 0 पे उसका force speed change नहीं करने की कोशिश कर रहे हैं. Let's see what happens the very next moment. What happens the very next moment? Because of this it will change its direction और इसका path कुछ ऐसा हो गया, ये ऐसा हो गया और यहां पे जो वेलोसिटी है वो मानना क्या है कि ये वेलोसिटी है. अब फोर्स की क्या डायरेक्शन है? फोर्स इज अलोंग द फील्ड एंड नाउ द फोर्स विल हैव अ कंपोनेंट अलोंग द वेलोसिटी. एक ये कंपोनेंट है फोर्स का और एक ये कंपोनेंट, वो उसकी स्पीड चेंज करेगा और ये इसकी, पर रेडियल फोर्स की वैल्यू कम हो गई, therefore the radius will now decrease and thus mv square, thus that path is parabolic. A parabola is a different circle all the time. Here it wants to move in a circle, but the very next instant the force will begin to make an angle. So if sometimes he asks you what is the radius of the trajectory at this point, you will say Q into E is equal to mv square by r. But that will not be the trajectory after point 0.00001 seconds. Thus, electric field which ऐसा कभी नहीं होगा कि उसकी स्पीड नहीं बदलेगी. That is why we say, because the moment the direction of motion changes, the direction of force doesn't. The direction of force doesn't. That's it is a beautiful thing. अगर मैं तुम लोग इन्हीं पैराबोला प्रूफ करा तो अगर आपको याद हो तो जनाब x is equal to v into t and y is half at square, which is half into qe by m into x square by, remember, and y is equal to, thus the trajectory is parabolic trajectory. Definitely a change in speed. V dash vector greater than. The importance of the entire discussion is that the direction of the force due to the electric field does not depend upon its velocity. It will always be along the field. And there will always be a component of the force along the velocity vector that will change its speed. यहाँ वहम होता है, इसीलिए ये discussion. It is simply a revision discussion. Let us come to our. इसका मतलब है कि इलेक्ट्रिक फील्ड के बीच में चार्ज पार्टिकल के ऊपर फोर्स हमेशा लगेगी और मैग्नेटिक फील्ड में जरूरी नहीं है. कब कब नहीं लगती? यार पहले रेस्ट वाली बात बोलते, आप पहले पैरेलल वाली बात बोलते हो। If the charged particle is at rest or it is moving, and the force is maximum if the angle is
90.
From our concepts of mechanics, we remember that if the force will be perpendicular to the velocity, there will be no change in its speed. Magnetic field में force is perpendicular to the velocity. But you say, sir, जैसे इलेक्ट्रिक फील्ड में हुआ, जब डायरेक्शन बदलेगी तो फोर्स की भी बदल जाएगी, such that the force will always be
Perpendicular.
Hence, in a magnetic field, there will never be a change in its speed, though a change in its velocity. Because the moment the force acts, the direction will change. But according to the new direction of velocity, the force will also change in such a way that it is still perpendicular to the velocity at any instant. Thus, this force will provide the necessary. Let's try to put this in picture. Okay? Motion of a charged particle in an external magnetic field. Motion of a charged particle in an external magnetic field. Consider a charge plus Q. Moving perpendicularly to an external uniform magnetic field. Uniform magnetic field एक ऐसी magnetic field होती है जिथे in that region the magnetic field is constant in magnitude as well as direction. आपको लिखना ज़्यादा अच्छा नहीं लगता तो हम यही elaborate कर लेते हैं instead of writing के the magnetic field is perpendicular to the current pointing into it आप यहाँ elaborate करते हैं B vector is actually B into minus K फिर कुछ लिखने की ज़रूरत नहीं V vector is V into I ठीक है ये चार्ज पार्टिकल प्लस Q यहाँ I force acting on the charge plus Q is F vector is Q into V cross B. As V is perpendicular to B, therefore F is a QVB. Direction is given by V cross B. हाँ जी करके देखोगे कैसे है कितना है V cross B करके देखोगे मेरे को अप डाउन इनटू प्लीज टेल मी व्हाट डू आई JK In which direction is the force acting? How can it be minus side dimension? एक मिनट isn't it? No. It will be plus J. ये देखो. If this is the palm of my hand is your notebook, then this is your magnetic field and this is your velocity vector. V cross B. ठीक है? Clearly, it is along J cap. A J force. F vector is perpendicular to V vector. इधर ना प्लीज ऑब्जर्व इधर और वेलोसिटी आ होगी तो ये वेलोसिटी हो गई तो अब v क्रॉस b करोगे तो फोर्स ये आएगी ये वाली फोर्स इसको ऐसे मोड़ देगी यहां वेलोसिटी होगी तो फोर्स ये आएगी ये वाली फोर्स इसे यहां मोड़ देगी और वेलोसिटी ये हो गई और फोर्स ये आएगी. Look at the way I've written the force. It is valid for any vector drawn anywhere. ठीक है? Do not put a vector here because the vector definitely changes. F is perpendicular to V at any point. Jada along J cap है, that is for at t is equal to 0. Clearly it is along J cap at t equal to 0. F is perpendicular to V at any point. At any later time, लिख सकते हो. At any time later भी है. At any time. Now लिख लो because due to a change of direction of motion. Because due to a change of direction of motion, the direction of force will also change. In a way that it is always perpendicular to the velocity. Hence, there will never be a change in speed. This force will provide the necessary centripetal force. This force will provide the necessary centripetal force. For the charge to move in a circular path. This force will provide the necessary centripetal force for the charge to move in a circular path. Therefore, QVB is mv square by r. लैंग्वेज की मैथमेटिक्स बना ली हम, और V is QBR by M. The time period T यूनिफॉर्म स्पीड है 2 pi r by v. And the frequency QB by
2 pi.
And my question is to Riddhi. Riddhi, a charged particle plus Q, it is moving perpendicular to a magnetic field. It enters the field with a speed v and describes a trajectory which is circular and takes a time t. Okay? The next time the same charged particle and the same magnetic field perpendicular to it but with double the speed. Till it will describe a circular trajectory. What will be the time taken now? Will it be the same, more or less? Same क्यों?
Depending on the velocity.
किस पे? बात तो ठीक है पर बात हजम सी नहीं होती है कि तेज आया शक्ल में घूम गया तो जल्दी करना चाहिए यार उसे, हजम सी नहीं होती बात. अरे वाह, अरे वाह. Actually V is proportional to R is proportional to V. That's good one, Jay. ठीक है, V is proportional to R. और यहाँ लिखो the time period is independent of V as well as R. Time period is independent of V as well as R. बड़ी इंपॉर्टेंट गाना है. Far-reaching consequence in tomorrow's lecture. इसका मतलब ये हुआ कि मैग्नेटिक फील्ड में चार्ज पार्टिकल की स्पीड कभी नहीं बढ़ेगी. इलेक्ट्रिक फील्ड में चार्ज पार्टिकल की स्पीड हमेशा बढ़ेगी. Even if the charged particle is moving perpendicular to the electric field, that is the t is equal to 0. At the next very instant, a change in the direction of motion will not change the direction of force, such that there will now be a component of the force along the velocity. I hope you understand this.
Yes.
But in the case of a magnetic field, if the force is perpendicular to the velocity, causing a change in the direction of motion, the direction of force will again change in such a way that it is always, if the force is perpendicular to the velocity at all times, there is never going to be a change in the speed. Very, very interesting. So now what you need to know is the trajectories of the charged particle in an electric field and in a magnetic field and for various angles. Charan, what is the trajectory of the charged particle in a magnetic field if it is entering the magnetic field parallel to the velocity, parallel to the magnetic field? Trajectory पूछी है मैंने तो. What is the trajectory of the charge? straight line without a change in its speed. यार फोर्स ही नहीं लगी, फोर्स ही नहीं लगी. अगर परपेंडिकुलर ही आता तो the trajectory is circular. वहीं पे घूम जाएगा, वहीं पे जहां आया है वो उसका एंड पॉइंट होगा, सेंटर नहीं. बच्चों को लगता है कि जहां आया है वो उसका, ये देखो सवाल आ जाता है. सो ट्रैजेक्टरी ਜਿਹੜੀ है ਇੱਥੇ आगे चलो शो हो रहा है वैसे वेलोसिटी नोट पर सवाल ही बना लेते हैं पहले, इनसे पूछते हैं Is there a change in kinetic energy? Where? There is no change in velocity. Are you sure there is no change in velocity? There is a change in its speed. There is no change in its speed. There is definitely a change in direction. Hence there is a change in velocity. Come back to question. Is there a change in kinetic energy? हाँ जी, बड़ा मजेदार चैप्टर है ये, बड़ा मजेदार चैप्टर. हाँ जी दीपाली जी, नो चेंज इन किनेटिक एनर्जी. पाहुल, व्हाई? डू यू नो हाफ एम स्क्वायर में v स्पीड होती है? बिकॉज किनेटिक एनर्जी इज वर्क डन एंड वर्क इज द स्केलर. लिखो जनाब, there is no change in the kinetic energy as there is no change in the speed. अगला सवाल मुस्कान में ही है. मुस्कान, is there a change in momentum? फिजिक्स वाले बदमाश होते हैं. Momentum m into v, v velocity. Kinetic energy half mv square, v speed. There is no change in the kinetic energy as there is no change in the speed. There is definitely a change in momentum. तो मेरे को बताएगी कि इस पॉइंट में और उस पॉइंट में चेंज इन वेलोसिटी का मैग्नीट्यूड क्या है? Be sure about it. What is the change in velocity का magnitude between this and the topmost point? का magnitude. There is no change in the magnitude of velocity. Remember? आहिस्ता आहिस्ता मैंने आपको +1 याद करानी है. यहाँ और यहाँ. चलो इतना कुछ नहीं लिखेंगे. There is no change in kinetic energy because there is no change in speed, but there is surely a change in, as there is a change in velocity. Chavi, what is the work done by the magnetic field? As it moves through 1/4 of a circle. शाबाश. ठीक है, बहुत important सवाल. There is always some work done by the electric field. I think you got a very nice hint from change in kinetic energy. Had I not asked you that, things would have been, you would have started to do, force into distance. So that question gave you a very good hint. सारा कुछ इकट्ठा लिखो यहाँ पे, पेपर में आता है. Clearly the work done by the magnetic field is zero. Because there is no change in kinetic energy. या एक और तरीका है, यार वर्क डन में तो सेंट्रीफ्यूगल फोर्स हमेशा 0 होती है. F dot ds is F ds cos 90. How much time did you give me? 10 minutes. Okay, wonderful. सॉरी, जो हमने डिस्कस किया अभी तक वो ये है that the trajectory of a charged particle in a magnetic field, if the charged particle enters the magnetic field parallel to the magnetic field, is a straight line without a change in its speed. If the charged particle enters the magnetic field perpendicular to the magnetic field, then the trajectory is a circle without a change in its speed. Let's see what happens if the charged particle enters the magnetic field at an angle.
चेंज होगा
Let's see. अपने पास 10 मिनट है. That's the last thing. पहले बता देता हूँ, समझ आएगी वैसे बड़ी अच्छी बात. If the charged particle enters the magnetic field at an angle, let's divide V into two components here. V cos theta along the field and V sin theta. V cos theta के कारण वो कैसे जाएगा? सीधा. Unmindful of the field है, सीधा ही जाएगा. V cos theta magnetic field को क्या समझता? सीधा जाएगा. पर हम सानू नहीं कोई समझता. If the charged particle and V sin theta जो है मैग्नेटिक फील्ड को ऐसे लगता है कि अगर परपेंडिकुलरली 10 मीटर पर सेकंड की स्पीड से आ रहा है, 30 डिग्री पे आया है, तो ऐसे लग रहा है जैसे 5 मीटर पर सेकंड से आएगा. मतलब रेडियस ऑफ द पाथ विल डिक्रीज. ठीक है, बट V sin theta will make it move in a circle.